Good evening. Hello, hello. Good evening. Audible? Sorry about yesterday. I had to leave midway. So you guys are watching in your phone or what? Huh? Okay. That's good. Nice. Good to have you guys. So, did you attend the class yesterday? In fact, I must tell you, I'm so happy that uh, you guys are attending, even though if this is this late. I'm happy. We'll solve 5 good geometry problems. Some could be very easy. One of them could be a bit harder. So let's see how geometry happens, right? So let's see how geometry goes about. So ready? Shall we start? Shall we start? Okay. So we'll start. Have a look at the first question. This is the diagram which I drew yesterday actually. So you may refer to the diagram, but first read the question. We have two circles S1 and S2. This is S1, that is S2 of radii 6 and 3. Okay, so that is S1 then. So that has radius 6 and this has radius 3. Okay, and they are tangent to each other externally. Let's say P is the point of tangency, right? They are externally touching each other. So they are touching each other at point P. And then the two external tangents, B common tangents, B AC and BD. AC and BD are two common tangents, and we want to find the area of the quadrilateral ABDC, right? So this is the diagram, that's the numbers. We have 3 and 6. Figure out what the answer would be. We want them to be the nearest integer answer. So have a look at it. I'll wait for a few minutes since it is live. Yeah? Okay. Okay. So first of all, something could be said. First, we need to see what happens about what about the common tangents, right? So if I have two circles of radius R1 and R2, this has R1, this has R2, let's say, and we have this common tangent. Yes, Sailesh, you are correct. Sailesh is correct. So this has center here. This is R2, this is R1, and this happens to be R1 plus R2, right? So let's say this is O, this is P. Then if I draw a perpendicular here, this length happens to be R2 minus R1. So we want to find the D. So we have a good right angle triangle and we have D square plus R2 minus R1 whole square is equal to R2 plus R1 whole square. And that gives you D square is equal to 4R1 R2. And that tells you D is equal to 2 root R1 R2. Right? So this is how it is solved. Yeah. If R1 was equal to R2, then we'd have the distance to be equal, right? So D would be R1 plus R2, which would be 2R. So here, this distance happens to be 6 root 2. Why? Because the D is AC is equal to 2 root 3 into 6. And 3 could come out, so this is 6 root 2. And we do see that triangle OAX, X is the center of this thing and Y is the center of this triangle. So triangle OAX is similar to triangle OCY. So that tells me that OA by OC is 3 by 6, which is 1 by 2. So OA has to be now half of OC. So basically A is the midpoint of OC. So that means this is also 6 root 2. And we have the same here. Now we want to find ABDC. Now if you also pay some attention, ABDC looks like it is a trapezium. It looks like this. This is how ABDC is, right? So we just need to find the vertical height and the basis, right? So we want to find, I named this point E and this point F. So we actually want to find EF. So the area becomes of EF into AB plus DC. This is the area we want to find. So let's look at a few more things. Anyone else trying this or not? Just joined, okay. Good. So I hope you can, scroll back and look at the question. I gave enough time. Now, look at this triangle OAX, right? Let's have a look at the triangle OAX. That is a right angle triangle because tangent and radius are perpendicular to each other. So this is OA and X. This is 3. This is 6 root 2. And if I draw a perpendicular, this is point E. Right? This is the diagram. Agreed? Hi, Jasmit Raj. How are you doing? So in this triangle, it is something very interesting because if this angle is alpha, then this angle would be beta. Then we know that alpha plus beta is equal to 90 degrees, pi by 2. Right? And we see that since this is perpendicular, this is also beta and this is alpha. So we have 3 similar triangles within this triangle. This is a very interesting structure which we have here. Right? We have 3. So what are the 3 triangles? I will have, of course, OAX. Triangle OAX is similar to A was this thing. So OEA. Okay. I have triangle OEA. A, and that is similar to triangle AEX, right? So we have three similar triangles in this. What do I think of Bangladesh Mathematics Olympiad? I have not seen it, so I don't think I have the eligibility to answer that question. I'm not sure. I'm really sorry about that. Sir, I haven't qualified NMTC stage 2. Fine, you have many other opportunities to prove yourself. Nothing to get demotivated about. Never quit. Never quit. Quitting, come on, yaar. What do you think? All the exams you attempt, you'll qualify with flying colors? That doesn't happen, right? That never happens. Almost never happens. So that's the truth of life. Okay. So don't worry about that. Okay. With Pythagoras theorem, we can find that OX square is equal to 3 square plus 6 root 2 whole square. It is 9 plus 6 root 2 is 36 into 2, 72. So it is 81. So my OX is equal to 9. Okay. So OX is 9. So if I want to find, let's say, I want to find OE, right? So let's look at this. OE by OA is equal to, here OA by OX, right? That's clear, that's obvious. So I can find OE to be, OE by OA was 6 root 2 is equal to 6 root 2 by OX, which is 9, which implies OA is equal to 8, right? Am I right? 9 gets cancelled, so it's 2 into 2, 4 into 2, 8. So this is 8, and hence this would be 1. So if this is 8 and 1, we know how to find AE. So our aim is to find AE, right? I can also do EA by AX. EA by AX is equal to OE by OA. So AX was, so AE by AX is 3 is equal to OE, which is, we just found 8, by OA, which is 6 root 2. So I have to do 3 2s are, and 2 to 4, so this is 2 root 2. AE is equal to 2 root 2. So I have this length to be 2 root 2. So in my diagram, this length is 2 root 2, and because of this similarity, this will be 4 root 2. And if that is 2 root 2, this is 4 root 2, what is the, and I also found OE, which was 8, which means OY, OF would be 16. So EF would be 16 minus 8, which is 8. So if I get back to this diagram, EF is 8, this is 4 root 2, this is 8 root 2. So now we know how to find the area. I hope this is clear. Right? Is that clear? So my area is, half into 8 into 6 root 2. 12. 48 root 2. And we want the nearest integer. So multiply it with maybe 1.41. And I mean, you do the math. I won't do that. So is that clear? Is this question? I hope it's totally clear. It's very easy, right? Okay, next question. Very easy. Solve it. I'll give you some time. Vedic Kumar, so did I clear your question? Don't feel demotivated. Come on. Huh? This is not final thing. You got a lot of opportunity to prove yourself in the world in your favorite subject. Yeah, you'll have numerous opportunities. Okay. ABCD BA square with side length 100 units, I suppose. A, B, C, D. And then a circle with center C and radius CD is drawn. So that would be like this. Another circle of radius R lying inside ABCD is drawn to touch the circle externally and such that the circle also touches AB and AD. Okay, so it is touching AB and AD and it is touching this circle externally. Okay, so this is inside here, a little ball over there, right? So is that diagram clear? Okay, that may be the answer. I'm not sure exactly, right? Let me just look at what is the answer. That should be embarrassing. Yeah, correct. Correct. Yeah, that was easy, right? This is actually, I think, quite easy to solve. So you have this, and the radius of this small circle is R, and we basically want to find R. What is R? So this is 100. This is 100. So if I join this, this is going to be 100. And AC we know is, by Pythagoras theorem, AC is 100 root 2. And this is R, this is R. And what is this length? Let's say this is O. What is OA? OA is also R root 2, right? Because these two will be touching there. So OA is equal to R root 2. So basically this is equal to 100 plus R plus R root 2, right? Only calculations are a bit painful. Okay. Yeah, this was very easy actually. I just realized it now. So, I mean, it just requires, so 100 root 2 is equal to 100 plus R plus R. So, R into 1 plus root 2 is equal to 100 into root 2 minus 1. R is equal to 100 into root 2 minus 1 by root 2 plus 1. That is simply 100 root 2 minus 1 whole square. So that is 100, 2 plus 1 minus 2 root 2. So 300 minus 200. So this is m, this is n, this is k, m plus n root k, and we want m plus n by k. It is 300 minus 200 by 2, 50. This was very easy. This was too easy, right? Yeah. Anyways, but those who are really beginners, I think they would find it, yeah, they would find it very, very interesting. Okay. Given a pair of concentric circles meaning same center and different circles, AB, BC, CD, etc. AB, BC, CD are chords for the outer circle, but they are such that all touch the inner circle. They are tangent to the inner circle. If angle ABC is 75, how many chords can be drawn before returning to the same point? Think about it. All the chords are of the same length also. I think that is not mentioned, but I think all the chords are of the same length. And this is making 75. So if we keep on continuing, if I draw a DE and EF and that and this and this, so when would it end up back at A? That is the question. When would it end up back at A? Sir, can you give time this question as well? Yeah, sure. Of course, I'll give time. Yep. Correct. So 24 is the correct answer. So the thing is, since all the chords are of the same length, when you look at the points which are touching the circle, inside the smaller circle, and you make these, since these two are 90, the inner angle happens to be, so if I have this like this. This is 75 degrees. These two are 90. So this angle happens to be 180 minus 75. So this is 105 degrees, right? And suppose we have a chord, the final chord, wherever that is. Sorry, why is it drawn like that? So this chord, the final chord, let that be in blue color. If the final chord is like this, then that would be making exactly 105 degrees here. That means whatever the number of chords which are adding up, this should be 105 degrees. And the next one should be 105 degrees. Right? The idea is that each of the 105, 105, 105, when they add up, let's say we have n number of such chords we need to get back our thing. So 105 degrees into n should be equal to 360 because we want to get back to A. So it should add up to it should complete the circle in some sense. So this has to be equal to 360 degrees ka multiple, so into something, right? Right? So is the idea clear? I hope the idea is clear, right? Chalo. So that ends up being very easy. So I just have to cancel out 3. So it is 3 times 30. 5 and 3 times 120, 5 times 7, 5 times 24. So I have 7n equals to 24k. And here we'll have to use a bit of number theory. Since GCD of 7 and 24 equals to 1 and n equals to 24k by 7 is an integer. That implies 7 has to divide k, implies least value of n equals, when k equals to 7, least value of n equals 24. So 24 is the answer. Is that clear? The session will continue maybe another half an hour, not longer than that. Right? Hi, Spidey. Kalyan, I think, right? Am I right? I don't know. So if that's clear, just tell and I will move ahead. A quadrilateral ABCD is cyclic, first of all, and AB is equal to 7, BC is equal to 24, CD is equal to 20, DA is equal to 15. Okay, damn, that's very interesting. The area interior to the circle but exterior to the quadrilateral. Interior to circle, exterior to the quadrilateral can be written of that form. What is A plus B plus C? Figure it out. It's a very good question. Yeah, hi. Is this AIME? I don't know. Oh, someone said repeat, please. So those who are solving this, pause the video. I'll go back and repeat the previous one. But you can watch the recording. See, the thing is, each of the two chords, two tangents, chords to the outer circle, make the angle 105, right? They make the angle 105. And we want that as we draw more chords, okay? Hi sir, I'm new to raise channel. Thank you for raising the channel. Yes. So as we draw the chords, we want it to end back to A. That means all these 105, 105, 105 must add up to get into what do you say? To be a multiple of 360, so that it completes the circle after multiple chords have been drawn, right? So that's the idea. That's what we did here. So 105 into n should be equal to 360 degrees multiple of a 360 degree. So that's the idea. So yeah. K is 234. Whoa, what? You see, this question requires a little bit of cosine rule. I hope everyone remembers cosine rule. Okay. Because I'm going to claim something. I claim that AC is a diameter. AC is equal to 25. AC is equal to 25. That's the claim actually. Yeah. Is the answer 1565? I don't know. I don't remember exactly. I'm really sorry about that. But we'll see. We'll see. I don't remember the answer. I don't even have it in front of me. Fact sphere. Sir, hats off to you. ठीक है. उड़ा लो मजाक. बड़ा होगा मेरा ऑडियंस भी यार. स्मार्ट लोग हैं इस दुनिया में. चिल. Okay. How do you prove AC is 25? Tell me. Getting the answer is easy. But the solution, I want the solution. I want the solution. Cosine rule, exactly. So that's what I was saying. That say AC was less than 25, right? Yeah. Pythagorean theorem. Yeah, that's also. Oh, we do have something called converse of Pythagoras theorem. So I think. But how do you even start with that, right? We have to think. If AC is less than 25, we know that first of all 7 square plus 24 square is equal to 25 square, which is also 15 square plus 20 square. Okay. So if possible, let's say AC is less than 25, that implies cos C, cos B is equal to AB square plus BC square minus AC square by 2 AB BC, and you'll see that this is less than 1, like positive. This is positive. If this is positive, that implies that B is acute. That implies that B is acute, and that will imply that, I mean, that's basically saying B is less than pi by 2. Similarly, I will also get that cos D is positive, and that will imply that D is also less than pi by 2. Is this clear what I have written? If the cos is positive, right? Some people are using Brahmagupta formula. Okay, you can use Brahmagupta formula, but I don't want to dare to do that. All right. Okay. But B plus D has to be pi. Why? Because it is a cyclic quadrilateral, right? Cyclic quadrilateral, the opposite angles add up to pi, but B less than pi by 2, D also less than pi by 2 implies B plus D is less than pi. So this is a contradiction. Right? So similarly, same way, if we assume AC to be more than 25, we'll get cos B to be less than 0, implying B is obtuse, and cos D to be less than 0, implying D to be obtuse. And that would imply B plus D to be more than pi, which is again a contradiction. Contradiction to what? Contradiction to the assumption. Therefore, AC is neither less than nor more than, so it has to be equal to, there is no other way. And the moment AC is 25, we see that that has to be the diameter. The moment that is the diameter, if that is the diameter, you know, that means this is diameter. So we can start with this being 90, this being 90. We can find the area of triangle ADC and ABC, and then we can subtract from this area. So is that clear? Is that clear? The method is clear, right? How to prove and all that. Yeah? If that's clear, we'll move to the last question, and then we'll end this live stuff, live thingy. Yeah? Chalo. This is the last question. This is the most interesting question actually, right? So we have an incircle gamma. So let me draw some random scale and triangle. I have incircle and touches. Okay, this is A, B, C, BC at D, E, F. Let RA be radius of circle inside ABC, which is tangent of gamma and sides A and B, AB and AC. So RA is here, and similarly there is an RB, RC. right? Tangent to the circle, but so we want R. We want to find R. What is R? It's a theorem. Okay. But here I am trying to prove it. Like the point of this question is that I will prove the theorem. The theorem says, there is a theorem, I think, what does it say exactly? Don't remember, but we'll prove it, right? I only thought about the proof. I don't remember the theorem exactly. So I think it is something like R is equal to square root RA RB plus square root RB RC plus square root RC RB RC RA. Right? I think this is the theorem. Yeah? Yeah. Got it. Just yeah. So there is a delay. So I think you'll see this after 30 seconds of what I have written. So yeah, got it. So we'll prove it. It's very easy. It requires a little bit of sine rule, not sine rule anything, but basic trigonometry actually it requires. So let's have a look. I have a triangle. This is A, this is B, this is C. I have an in circle and I have this circle, let's say, right? The in circle does not look like an in circle. Okay. Now this is the center. If I join this, now you should know that the in center is the intersection of angle bisectors. I hope you know that. Why is it the intersection of angle bisectors? Because if I have any two tangents, I have done this in circles class, one of the circles classes, that if you have two tangents, that means this has to be bisecting, right? For the exact same reason, this angle is C by 2. And you see, this, since these two are tangent externally, these two circles, this is RA and this is R. Now tell me, let's say this is O, let's say this is, oh, this is C, RC, OC, right? Since this is 90 degrees, R by OC is what? R by OC is what? I hope everyone knows this. R by OC is sine C by 2. So that implies OC is equal to R by sine C by 2. And what is similarly, what is RC by OCC? That is also sine C by 2. And that will imply that OCC is also equal to RC by sine C by 2. Why am I doing this? Because the difference is known. This is R, this is RC. So, OC O is equal to OC minus OCC, which is R plus RC. So OC minus OC, OCC. Okay, that's very funny when I say this, but yeah, that's how it is. So let me write it down. R plus RC is equal to R by sine C by 2 minus RC by sine C. So that implies R plus RC by R minus RC is equal to 1 by sine C by 2. So what do we do from here? We use componendo dividendo. component to dividend. So what do we get? R by RC is equal to, so I'm adding those two, 1 plus sine C by 2 by 1 minus sine C by 2. Yeah. Square root R is equal to square root A, RA, RB, RC. Okay, I'm not sure of that. I don't think that's correct. I think there's something wrong with that. Anyways, so this is the thing. What do I do? What can I do in the right hand side? What can I do in the right hand side? Anyone? I hope we remember that 1 plus sine A is equal to sine A by 2 plus cos A by 2 whole square, right? So this is equal to sine C by 4 plus cos C by 4 whole square by sine C by 4 minus cos C by 4 whole square. In fact, this is 1 plus tan C by 4 by 1 minus tan C by 4 whole square. In fact, so this becomes R by RC becomes tan square C by 4 plus pi by 4. So that implies tan C by 4 plus pi by 4 is equal to root R by root R, R by RC. Tan A by 4 plus pi by 4 root R by RA. Tan B by 4 plus pi by 4 is root R by RB. So what do we have with A, B and C? A plus B plus C is equal to pi. A by 4 plus B by 4 plus C by 4 is equal to pi by 4. But A by 4 plus pi by 4 plus B by 4 plus pi by 4 plus C by 4 plus pi by 4 is pi by 4 plus 3 pi by 4. That happens to be pi again. Right? Is that clear? It's not pi by 4 minus x by 4. No. That is plus, right? I didn't make any mistake, I hope. So this was plus 1 plus tan C by 4 by 1 minus tan C by 4. That is tan of pi by 4 plus C by 4. So I hope that's not wrong. There's no mistake in there. Right? So the moment we have that, for three angles x, y, z. So let's say these are x, y, z. So if x plus y plus z is equal to pi, that implies, what do we have? Tan x plus tan y plus tan z is equal to tan x, tan y, tan z. Right? So if I take each of these to be some x, y and z, x plus y plus z is basically pi. So I will have the exact same relation as, oh, I am out of slides, so I'll go back somewhere. This is unfortunate. So root of, why? Root of r by ra plus root of r by rb plus root of r by rc is equal to square root of r by ra, r by rb, r by rc. So if you get this, this is actually r root r by root of ra, rb, rc. So I can cancel out one of the roots, right? The numerator will be cancelled. So I basically have 1 by root ra plus 1 by root rb plus 1 by root rc is equal to r by square root ra, rb. So we have r is equal to root ra, rb plus root rb, rc plus root rc, ra. This is the proof. This is the proof. Pit stop. Whoa, what does that mean? So is that clear? It was fun. I enjoyed it thoroughly. बहुत मजा आया यार. Thank you for staying this long. It's already 11:10. I started a bit late and everything, but it was great. It was awesome. Right? Chalo. So if you have nothing else to share, ask anything, so I'll just end the session and I'll say bye bye, good night. You did something else? Yeah. Please share it. Please share it. That's awesome. Right? It is interesting. I'm really glad. What do you mean by box? Box? Where do I have box? Do I have box? Where? Okay. I hope that is cleared. You think you have solved 50% of Riemann hypothesis? Good for you. Amazing, yaar. Amazing. Chalo, I'm going to end the session. Good night. Thank you so much for staying with me. And I turned 1 minus sine c by 1 plus sine c into cosine. How would you turn that to cosine? How would you do that? Did you rationalize the denominator? That type of a thing, is it? Then tan square. Oh, I did tan square, right? Like, was it different from this? I hope not. I hope like it's very similar. I think. Yeah. Chalo. Anyways, thank you guys. Good night. I'm glad Lewis proved 1 plus 1 equals to 2. Crazy stuff, man. Crazy. Pi by 2. Oh, okay. Ha. That I get it. Yeah, I get it. Understood. That is easy. That is then you will get in terms of A plus B, right? Jasmith. I was in which college? I was in Indian Statistical Institute. Yeah. Yes, got it. Jasmith, amazing. Yeah. Yeah, that works. Jasmeet, yeah, that works. Chalo. Integration problem which can be solved without integrating. Amazing, yeah. Share it in the group. These kind of things are very interesting, Ashutosh. Please join the Telegram group. Go down to the Vedanta Olympiad school thing. Join the group. We have a group, right? So if I could show, I would love to. So if I have to show YouTube, okay. Ashutosh, I'll be really interested to know that. Yeah. So if you join the group, you'll have this Telegram thing, right? And in fact, I would actually prefer you join the group directly. I have recently posted the group link. So you can join the group directly from here, this post. So you teach better than me. More than welcome. Why are you watching me, man? Just get out of here. Don't watch me. Don't watch me. Yeah. So what was your maths percentile? I don't remember, man. Probably 99.2 something, 99.45. I don't know. So my name is Achintya. This is my father's account. Oh, Achintya, yeah. Achintya, join the group. Join the group, and you can share whatever you want. কেমন আছো? আমি ভালো আছি তো, খুব ভালো। তো ভালো তো, ঠিক আছে? I do watch 3 Blue 1 Blonde. I prefer Veritasium actually. Are you racist? Then why are you watching? What's wrong with this guy? Yeah, Achintya, join this group and share it. Right? I promise you, it will be worth your while. And whoever is new to this channel, I will welcome you to the group. Right? Go to the posts. Where's English? Post this link. Right? That's all. That's all I've got. Chalo, then. I'll say bye bye, good night. Calculus session will be coming this weekend, guys. This weekend, I had dinner. Thank you. Thank you for asking me. Yeah, Oasis, join this group and challenge me. You're welcome to. Yeah, Oasis nahi hai. Sorry, naam galat pada tha. Oasis, join the group and challenge. You are more than welcome to challenge me. Right? I did have dinner. Thank you. Calculus will be starting this weekend. I'm not sure how many. So I think I'm planning like 2 to 3 sessions per week. Right? Or that's it. Akshit. Yeah. Bye. Good night. Take care.